We tasked ourselves to develop a video explaining the use of SUVAT in mechanics and how problems can be solved in real-life situations. Kinematics is the term used for the study of a body or particle's motion without reference to the forces that cause that motion. There are three types of kinematics: motion in a straight line, motion along curved lines, spinning or orbital motion about a point. During the duration of this video, we will be explaining motion in a straight line in large detail.
Particle kinematics includes the vector quantities of displacement, initial velocity, final velocity, acceleration, and time. Vector quantities have both magnitude and direction, whereas scalar quantities only have magnitude.
Rectilinear motion is the movement of a body in a straight line, like the ball dropping vertically in this video.
In an example to show rectilinear motion, we dropped a ball from a height of 1.5 meters from rest. Using this information, we are able to solve the final velocity when it hits the ground and the time it takes to hit the ground.
To solve the vector quantities, we need to use the SUVAT formulas that we know. To calculate the final velocity for when the ball hits the ground, we will use the SUVAT formula v squared equals u squared plus 2as. This is because we know the values of initial velocity u, acceleration a, and displacement s.
To solve final velocity using the SUVAT formula, v squared equals u squared plus 2as, we have to input our known vector quantities into the formula to give v squared equals 0 squared plus 2 times 9.81 times 1.5, which makes v squared equal to 29.43. To get v squared to v, we have to square root both sides, making v equal to the square root of 29.43. Calculating this gives v to equal 5.42 meters per second.
Now we know the value of final velocity, we are able to calculate the time taken for the ball to reach the ground from when it was dropped. To calculate the time, we will use the SUVAT formula v equals u plus at. This can be rearranged to make time, t, the subject, t equals v minus u over a.
Inputting the values of final velocity, initial velocity, and acceleration into the rearranged formula, t is equal to v minus u divided by a. This gives t equal to 5.42 minus 0 divided by 9.81. Calculating this gives t equal to 0.533 seconds.
In this example, a ball is kicked vertically upwards with a velocity of 15 meters per second. We will calculate the maximum height of the flight of the ball and the time taken to reach that point.
For this example, we will first calculate the time taken for the ball to reach its maximum height in flight. We will do this by rearranging the formula v equals u plus at to give t equals v minus u over a. As acceleration is acting in the opposite direction to the ball, we will give it a negative value.
To calculate the time taken for the ball to reach its maximum point in flight, we will use the rearranged SUVAT formula t is equal to v minus u divided by a. Inputting the known values, we know that t is equal to 0 minus 15 divided by minus 9.81, and so t equals minus 15 divided by minus 9.81. Calculating this gives t equal to 1.53 seconds.
To calculate the height of the ball at its maximum vertical displacement in flight, we will use the formula s equals v minus u divided by 2 times by t. Our known values are u is equal to 15 meters per second, v is equal to 0 meters per second, and t is equal to 1.53 seconds.
Inputting the known values of initial velocity, final velocity, and time into the SUVAT formula gives s is equal to 0 minus 15 divided by 2 times by 1.53. This calculation gives displacement equal to 11.47 meters. The ball is kicked at a height of 0.5 meters, therefore the total height is equal to 11.47 meters plus 0.5 meters. The total displacement from the ground to the maximum height for the flight of the ball is equal to 11.97 meters.